Hi, my name is Jarek, and on behalf of the Adaptive Vision company, I wanted to give you a short presentation on the newest addition to our deep learning anomaly detection tool called Golden Template. At the time of making this video, version 5.1 is still in the early beta stage of development, so it's a good moment for you to learn what exactly is in store for you. As part of this presentation, I'm going to be inspecting those plastic cable connectors like this one. So without further ado, let's begin working on our application. Beforehand, I made some images of the object in question. There are 6 objects. Each of them was photographed 6 times, which gives us the grand total of 36. Which shows you that you do not need to have so many samples ready to create a reliable model. As you can see, their placement differs slightly. We also have some NG images, 5 of them. Again, this is the same object on all of them. As we can see, there is a feature here that needs to be marked as NG. So let's open Adaptive Vision Studio 5.1, which is again it's the early beta version. Again, we're informed of this, and a proper warning is displayed here as well. So let's begin by grabbing the camera feed. For that to happen, we need to select from the toolbox and the image acquisition category, we need to select the correct standard that we're going to be using. In this case, I'm going to rely on the Genicam standard with which the Basler camera is connected to this computer. We'll need to first start acquiring the camera feed. So let's insert this filter. And then we need also to grab consecutive image frames using the grab image synchronous filter. By default, your application will be composed of 2 sections, a acquire section and the process section, both of which will have filters inside them executed iteratively, which is fine for the grab image filter, but not so much for the start acquisition filter, which we want to be executed only once at the start of our program. So what do? We display new sections, such as the initialize section, which will do just that. It will execute filters inside only once at the start of the application. And the grab image filter can be moved to the acquire section. Now we need to set the address. We can see the camera here. We can do it manually for the parameters, but it's a better practice to go to the Project Explorer and create a new global parameter, which we can call get Genicam address. We select the type gen address. We find the initial value for the Basler camera here. And the reason why we did this is that now if we connect the global parameter here to both these filters, if we introduce any changes to the camera, we can do it via the global parameter. So we'll not have to go through every single filter and perform changes manually, which is going to be very useful. So let's see whether we can get the preview as we wish it. And yes, that's exactly what we can see. This is the real-time. This is actually the NG image. This is actually the NG image I showed you before. So everything is in order. I think we can start working on our HMI. Let's hit the HMI designer. Now we have a new menu popped up. Let's undock it for easier editing. Let's also increase the HMI canvas. And first off, we need to see the camera feed, which we're going to use via the view to the box control. Let's connect the out frame to output to the in-image input. And let's also label it. Let's also give it a label by the label controls in the control section. let's call it camera feed. Let's increase the size of the font to 20. Yes, and let's see how it works. It's fine, but it's only part of the image seen by default. So let's stop it. Let's set the initial size mode to fit the window, and now it should be fine. Yes, everything's okay. All right, so now we're ready to start working on our deep learning model. Let's go to the toolbox. Let's go all the way to deep learning category, and let's find the deploy filter and put it in the initialize section. We need to deploy the detect anomalies to filter tool. And this is where we start working on our model. We need to select the model location on disk. We enter the directory we've seen before. We create a new folder. Let's call it test model. And now we are in the deep learning anomaly detection tool model editor. First of all, let's set the network type to golden template. The original anomaly detection tool operated on the single class manner, meaning it was looking for just one feature and marked all the anomalies, all that didn't conform to this one single class, which made it very applicable for textile inspection or some kind of wood inspection or any kind of uniform surface inspection. But the golden template here works differently. It's a much more complex tool that will allow you to directly portray anomalies not just of a single class, but however many classes there will be as part of the golden template that the model will find based on the OK images, and then will determine anomalies from. So now we need to upload images. Once again, let's find all the OK images. Let's drag and drop them here. We can label them all as OK instantly. And we're going to use them as part of the train set, all but 6 of them. The last 6 of them are going to be part of the train set. Those will be part of the test set. And also, we're going to add the NG images, again, as part of the test set, and we mark them as NG. Never use NG images for training a golden template model. The NG images are for test purposes only. So now we have our images, and now we can set our training parameters. Let's begin by the downsample. Should we downsample? If your image exceeds 1024 pixels in width, then perhaps we should. In this case, those images are large enough, so I'd say that the factor 2 of downsample should be sufficient. The model size, the predicted model size, was quartered. Now, it was 1 GB originally. Now it's just a bit over 200 megabytes. The max translation parameter determines the tolerance for the object shifting across the camera field, the field of view. And in this case, we want to increase it again by seeing the model size reduced to 96. The model complexity is a parameter that we may leave at that point. Only later, if you determine that the model is not accurate enough, and maybe it could be executed faster depending on your preferences, you can either increase it up to 28 or reduce it to however much you determine. Generally speaking, the lower, the faster but less accurate, the higher, the slower but more accurate. Now let's set up the augmentations. We have the rotation angle of the random rotation angle for the sample, the model sample. Let's set it to 5. No flip up and down and left and right are allowed because the model is not symmetrical. It will always look more or less like this. So that's a false of them. No relative translation as well. The minimum scale is theoretically not technically not necessary here, because the object is always going to be the same size, but it's always safe to give this 1 to 2% worth of tolerance. The shear vertical angles going to be and horizontal angles are going to be left as they are, but we can set the noise as assigned to the sample to 2%, as well as the luminance. And we don't need to do anything else. Let's hit start service. And you should be advised that it may take a while before the service is actually up and running, especially if it's the first time you're running it. So now we're ready to begin our training. Let's hit train, and I'm going to lower my camera view here just so we can see the result analysis. The training on detect anomaly detection tool proceeds fast, just 4 stages of training, and then the model is saved and the score is computed against all the images, not just the test images, but also train images, to determine the boundary between OK and NG. We're almost done. Okay, so now let's see how it worked. The NG feature was marked prominently on all these NG images, but as we can see, the OK test images were also marked as NG, as we can see from the red frame around them. Why is that? They scored higher, but why were they classified as NG? That's because the boundary of the results analysis was set too low. We can, however, increase it. And the reason why we can do it is because we can see that the gap between them, between the actual good images and the bad images, is large enough. So we can safely assume that the tolerance should be increased somewhat, and even if those test images were determined to be a little bit different than the others, they should still be considered okay, and every image within this spectrum should be also considered okay, as opposed to those NG images and the like. So now we are free to save and exit the model. Let's shut down the deep learning service, as we'll be advised to do if we want to run the application. And let's now add the detect anomalies to filter here to combine to execute the model against the frames coming from the camera. So we connect them like this, and let's minimize the HMI designer for now. Let's display heat maps on the frames. Let's wait for the model to be deployed. It takes a while. As we can see, there are several heat maps that were displayed here, especially the very prominent feature right here. But there's also some other things. However, just because a heat map was detected does not mean that the overall object will be classified as NG. Heat maps might be marked, but the object will still be considered okay, just because it is its overall score is kept within the acceptable limits. For the purpose of our HMI, I suggest that we combine the heat maps with the actual image. Let's connect the out frame to heat maps via the visualize heat map filter. And let's see how it works. Again, let's wait for the deploy. There's a lot of green here, so I suggest we increase the percent fuzziness to perhaps 5. As we can see, now we have this feature right here marked prominently. And now let's move to the HMI. And my idea for this is that we want to see, let's copy the view to the box, we want to see the results of the inspection right here. So of course we connect the visualize heat map to in image input. We copy the label as well. We're going to give it the name last inspection result. However, we will also want for the status and the score to be displayed on the HMI as well. So let's get back to the HMI controls. Let's find the pass-fail indicator in the indicators category. Let's connect the out is valid output to the control, to this indicator. Let's also find the label. And the label will display the score. And let's give it the default name of the score will be displayed here. Let's increase it to 10. And this one, this indicator will also be given a default name of status. And let's see. As we can see, the image was considered fail. The score is changing continuously, but it is still most definitely an NG. And that makes it very, very clear to the user. But let's make one final tweak on it. Let's make it so the inspection will only be performed if we click a button. Let's actually add this button right now, the impulse button, and let's give it a name inspect image. And so how do we make it so the inspection will only be applied if we click it? The out value will then, upon clicking, will return true, and only then should we enter this inspection. So what we need is first, let's put the deploy filter here in the vicinity. Let's mark all free, right click, and extract the variant step macro filter, which we will call should inspect. The macro filter was created, and we can fill the condition here. If it's clicked, it returns true. If it's true, then it should enter this macro filter. The false variant is empty, and in the true we have our inspection. Let's also add sections here, and let's put the deploy filter here in the initialize section, and now we're free to run it. Let's see, and now nothing happens unless I click inspect image. Again, we have a fail, and this is just one image. It's not continuous feed. The good thing about it is that now we don't need to wait so long for each time we want to start the program, because we're not always going to have to deploy the model. So let's use some other images. Let's see this one. This image passed inspection. We can see the score. Again, this is a stable score because it's again just one image that was inspected. Let's see this object. Again, pass. Let's see this object. Oh, we have a fail and a quite large score. What happened here? Well, those two pieces are obviously ripped apart from one another. That's a definite NG. So that's very good for the model to inform us about this. Let's have a look at this image. There's something wrong here as well. That mark definitely looks suspicious, so again, it's good for the model to inform us about this. And this object is okay again. And that basically concludes my my presentation. I hope you found this informative and that you will be interested in in the anomaly detection tool called Golden Template as soon as it's out and free for you to use on your production line. Thank you again very much for your attention, and I hope you found this video informative. And if you have any question, I'm sorry, if you have any questions that I suggest that you drop us an email at this address, and we'll gladly assist you in whatever it is you might require. So thank you. I'm sorry. I of course mean. I mean this address. I'm sorry. I forgot to change the view. So thank you again, and hope to see you next time.